Okay, on to problem set, homework set 31. We're going to do 4 problems here, primarily on page 458. The first was on 457. And it's got a long title, Resolving Trig and Inverse Trig Composite Expressions. And this is the expression in problem 12. I hope you appreciate that these videos are just getting more sophisticated all the time. This time it's early in the morning, so I'm experimenting with product placement. There we go. So let's see how this goes. Resolve tan arcsine of minus 1/2. So the first thing to recognize is that these arc functions, this arcsine, is an angle. That's why it's sitting in the argument of a tangent. Okay, and in fact, let's just let this angle arcsine minus 1/2 to be equal to theta. All right. If I can find theta, I can find the tangent of theta. So that's what we're all about here. So let's do the following. Let me draw kind of a virtual unit circle here, and inside it I want to draw the angle theta that has a sine of minus 1/2, because that's what this is. Right? This says the arcsine of minus 1/2 is the angle whose sine is minus 1/2. So I can think of a couple of different ways to draw that. I can draw this right here. There's the sine, there's theta, there's minus 1/2, there's 1. Opposite side over the hypotenuse is minus 1/2. There's a perfectly decent triangle with an angle theta. See, it would not have been correct to draw this one, right? Here's another theta angle right here, but its sine is positive 1/2. So I said let's draw this virtual unit circle. Unfortunately, I'm giving you too many insights into how my stupid brain works. But I did that so that I can sort of draw this triangle over here. Here's theta, here's 1/2. I'm gonna kind of just remember that that's minus 1/2 and 1, and it's actually the orientation that helps me remember that it's minus 1/2, right? I mean, the length of the side is 1/2, but in the unit circle it has this orientation such that you would think of this as minus 1/2. And okay, if we're in a triangle whose hypotenuse is 1 and whose short side is 1/2, then either you can tell immediately that this is the 30-60-90 triangle, or you could have resolved that from Pythagorean theorem, because after all, the hypotenuse squared is equal to this side squared. Let me say 1/2 squared plus this side squared. And so when we solve this, we see that x is equal to √3/2. Okay, enough. So I've drawn the triangle, I've drawn theta inside that triangle. It is the triangle that contains theta whose sine is minus 1/2. Let me find the tangent of theta. Pretty easy. Here's theta opposite over the hypotenuse, opposite over the adjacent. So the tan of theta is the opposite. I'm going to remember it's minus 1/2 all over the adjacent, which by the way is positive √3/2. And so if I resolve that, the 2's go away, I get 1 over √3 minus √3/3. And that's the answer to this problem right here. Cheers.